Last one, we've made it. All right. Very similar to the previous example. We are just going to build this truth table to build these two statements separately and compare all of their outcomes. So true, 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 false, false, true, false, false. Now, this one is the basic statement. There is nothing extra, just that one conjunction. Over here, we have several things going on. The dominance of connectives means parentheses go first, but then within those parentheses is what we have to figure out first. So really, we have this first, that not Q. Then we have P implies not Q. And then we have the negation of that entire statement. So we have to start with not Q, then we'll have P implies not Q, and then we'll have the negation of the entire P implies not Q to build out that third statement. For that and statement, it's only true when they're both true. So true, false, false, false. Not Q is the negation of the Q column. So false, true, false, true. P implies not Q. So we are building a one-way conditional on these two columns here. All right. With the one-way conditional, it's only false when it goes from true to false. So number one or the row one here, true to false is false. Then we have true, true, true. False, true, true, true. And finally, we just needed the negation of P implies not Q. So it's going to be true, false, false, false. To determine if they're logically equivalent, we have to go back and actually analyze the two statements we created. There was the first. Here was the second that we created. Looking at all of these values, we have trues to start, false, 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 which means these two statements are logically equivalent. Please note the way I asked questions on here. This will be very similar to the kind of questions you can see on the assessment, but also there is that online review where you can try multiple versions to hopefully help you get a better hang of these kind of concepts.